and our social media. As I mentioned before, we will be asking the questions. Sally got some questions as well at the end, and thank you very much.
Thank you.
So our next speaker is Dr. Xiang. He is a research associate working in the Center of Digital Build Britain, CDBB, and the Institute for Manufacturing at the University of Cambridge. His research interests are the development and application of digital twin to support better informed asset management, decision-making in buildings, and the wider built environment. The floor is yours, Dr. Xiang, and if you could please share your presentation. Thank you very much.
Thank you, John, for your introduction. Can you see my screen now?
Yes, I can see your screen.
Okay, thanks. Okay, good day, everyone. So the topic of my presentation today is shaping the future building environment, digital twin and its application in the post-pandemic era. And as we know, we are living in the digital age. Various digital concepts and technologies are emerging to transform our building environment into a digital, productive, and reliable one. These technologies include, but not limited to, AR, VR, robotics, IoT, artificial intelligence, and these technologies act as the extension of our eyes, our hands, and our brains. And on the journey of digitalizing the building environment, we have to recognize that the process of digitalization is quite expensive. For such a large-scale system, full digitalization is not realistic, not only from the perspective of expenditures and the investment needed, but also from the perspective of values and benefit that we can really gain from adopting these technologies. So in some sense, digital twin is actually a combination of technologies that tries to balance the cost and the benefit. By definition, digital twin is a digital replica that tries to mimic the behavior of its physical counterpart. And importantly, it sets up the digital paradigm to unleash the intangible values that people are pursuing, and also provide pathways to meet the expectation from the participant, including but not limited to the asset owners, the operation managers, and the end users. Functionally speaking, the digital twin aims to integrate data from different sources in an interoperable way and add structure to unstructured data. Meanwhile, it managed to accommodate and certain information in the modeling process and describe the building environment in a federated way as system of systems. So, founded by UK Centre for Digital Build Britain, the West Cambridge Digital Twin Research Facility project aims to demonstrate how a dynamic digital twin of existing building and campus can be developed, and also explore the opportunity and challenges that is brought from the adoption of digital technology. This project is collaborating with a lot of industry partners like Bentley, Topcon, and some startup companies as well. So in this project, the digital twin has verified its efficacy in the operation and maintenance phase, which is the longest and the most concerning phase within the lifespan of the building. First of all, we have to distinguish the difference between the digital twin and digital model as well as digital shadow. So actually, digital twin integrates a two-way data flow between the digital model and the physical object or the system. So the two-way data flow of digital twin instance makes it possible to estimate the as-is condition and predict the what-if scenario, which is the foundation and basis for many applications that we developed. To construct a digital twin model, there are three important elements. The first important element is the data acquisition technique that gathers the data from different sources. And in many cases, this data this data needs to be joined together to function. And the second important component is the BIM, which is now in many cases implemented with semantic web technologies to describe the connectivities between the different objects in the building. And last but not least is machine learning techniques that enable the data analysis and that tries to tries to improve the efficiency in the daily facility management and energy management. In terms of the implementation, data from different sources are collected throughout the pilot building. As we can see in the picture, the RFID-based IoT sensors are deployed in the building to collect massive data, such as the temperature, the space temperature, humidity, carbon dioxide concentration, and also the pump vibration. Meanwhile, the data from inherent systems, such like building management systems, are collected as a reference. And it's worth mentioning that a mobile phone app was also developed with a startup company called Redbyte. And this app, which is called Itemit, tries to establish a asset tracking network that collects the feedback from occupants and use natural language processing to prioritize this task. And beyond that, the building information modeling, or BIM, which serves as the data repository, associates time series data from different data silos through the defined connectivity between BIM objects. And last but not least, machine learnings are used to extract patterns from this data and support applications like predictive maintenance. And as mentioned earlier, for BIM model, different level of details are described and used because it is kind of a waste to model every corner of the building in the very fine granularity. And here I would like to talk about one of the applications or one of the case study we have conducted using the capabilities from digital twin. So as we can see that digital twin established can be used to support asset anomaly detection function. The adoption of digital twin could completely change the facility management process. The conventional process mainly have two defects, which are the fragmented information and the mutual and the manual query process. Let's take an example. For instance, when the FM professional receives a maintenance request from the call center, what he needs to do is, first of all, they need to search relevant information on the failed assets saved in the asset management system. And then they have to confirm the location from the space management system as well. And if further information is needed, they might need also to check on the building management system to check the latest status or the latest condition of the asset that they feel that they're interested in. So the duplication of information query frequently occurred in the conventional process is very concerning. So, but in this case, when the digital twin is adopted, the information from different systems is integrated efficiently, which facilitates better information acquiring and support better informed decision making and realize semi-automated or fully automated process. And this is the outcome of this example. And also, the digital twin can be used to support different functionality and services. And we have introduced this piece of work in a journal paper that we published. Meanwhile, considering the open nature of the digital twin, other digital technologies can be easily incorporated within the framework of the digital twin. Here we give example of the augmented reality-based visualized inspection tool. We know that many assets are beyond the eyesight of facility managers. for instance, the pipelines in the walls or the air ducts above the ceiling. So it is pretty hard for the facility managers to understand what happened in the building and also understand their working condition in their routine inspection and maintenance activities. So we have developed the AR HoloLens app which aims to help the facility managers to see these assets visually and monitor their real-time data with the help of digital twin model. So next, I would like to briefly discuss about the applicability of digital twin in the post-pandemic period, because we know that the interaction between human and the building are quite intensive, and this kind of interaction could be in different forms, like people could open and close windows when they feel warm or cold, or they could turn on the HVAC system and etc. And since the digital twin is based on the data, so the dramatic change of the way that people use the building could inevitably influence the functionality of digital twin as well. So we have tried to answer the question that whether the historical data collected and the machine learning solutions developed before the pandemic can still work in the post-pandemic situation. And I'm not going to give a very brief introduction about this piece of work. So you can find it in the other journal paper that we published. And in this piece of work, we have tried to review 6 different categories of applications in the area of facility management and asset management. And we tried to see the potentials, the possibilities of using the digital technologies, the digital twin technology still in the post-pandemic period. And we come up with 3 mitigation measures that could restore the functionality of these applications in the post-pandemic era. And I'm just going to give you a very simple example. So for instance, as you can see, the hourly building electricity consumption profile before and after the pandemic is just like as shown in the figure. And what we do is we adopt a Gaussian mixture module-based cluster to cluster the daily energy usage profile. And as we can see, before the pandemic, so as we can see, there are 2 transition times, which is at the end of March and at the end of June in 2020. And this cluster of DEU, which is the daily energy usage, almost get back to normal after June, although the energy usage is still quite low, which suggests that although the building is not coming back to normal, but different types of activities has just recurred in the building with restricted intensity. So it shows that there are possibilities to make best use of the historical data we already have and see the possibility of using the digital twin technology to help people to do exactly the same thing after the pandemic. So that is my presentation, and thanks for your attention. So if you have any question or doubts, you can also contact me by the email. Thank you.
Thank you, Xiang, for the presentation. We will be asking the question later, and I have a question as well about it's quite related to something I'm working on as well. We are going to be taking a very short break, about 5 minutes, and we will be back since it's quite a long session. So we will be back in 5 minutes, guys.